Hi, my name is Beth Barabalt, and this is a pre-recorded talk for the 2022 Society for Mathematical Psychology Virtual Conference. It's increasingly common to see psychological research that incorporates Bayesian modeling, including Markov chain Monte Carlo methods. In particular, I've noticed this in the cognitive modeling community, where those who have used maximum likelihood estimation methods are beginning to try out Bayesian methods for cognitive model fitting. In particular, STAN has been a popular choice of software to automate MCMC sampling. Because STAN implements Hamiltonian Monte Carlo, it's generally more efficient and capable than Gibbs sampling. However, HMC does require additional computational checks, and recent advances in Bayesian statistics have further extended the list of required computational and visual checks. So, in contrast to the classic diagnostics of R-hat, number of effective samples, and trace plots, the number of things we need to do is growing quite long, where there's now a updated version of R-hat and multiple effective sample size estimators, and if you're using STAN and Hamiltonian Monte Carlo, you'll also need to check divergences and Bayesian fraction of missing information by chain. There's also a suite of recently developed diagnostic plots that are strongly recommended. And while there are libraries available in R and in Python to automate these checks and plots, for those who are MATLAB users, there have been no such resources. That's why I sought to develop the matstanlib library in hopes of filling this gap. So in this fast talk, I'm going to review the quick start guide for matstanlib and just walk through some of the visual plots that you would get in the library. So once you verify that you have a working installation of STAN and a MATLAB interface to STAN, you can clone the code from GitHub and then just add the matstanlib folder to your MATLAB path. Then when you run STAN models and your interface returns the STAN output to the MATLAB workspace, you can use matstanlib to convert that output into a more standard format. And this extract samples function is compatible with all of the MATLAB interfaces to STAN. Then you can use the posterior samples to compute summary statistics and convergence diagnostics using the MCMC table function, which will return a table like this, which looks like what you would get in R or Python. And you can run a full set of automated diagnostic checks, which, if you pass all the checks, will look like this. But if you failed one or more of the MCMC computational checks, then you'll get more detailed output. And you can follow up on that output using the wide variety of diagnostic plots that is offered by matstanlib. For example, if you have a high R-hat, you can investigate that with trace plots and rank plots. For low effective sample size, you can investigate that with the trio of effective sample size plots, including efficiency for iteration or evolution plot, a quantile plot, or a local interval plot from left to right here. Also, you can use energy plots to investigate low BFMI warnings, and you can use plots like this one to investigate which parameters might be driving the divergences. You can also investigate divergences with other plots because many plots offer diagnostic overlays. Moving beyond diagnostics, you can also use matstanlib to visualize your posterior samples. You can visualize bivariate densities to notice funnels, correlated parameters. You can explore posterior densities and estimates and varying levels of depth. You can visualize individual, group, etc. differences. And all of these plots are highly customizable so that they can be publication ready. You can also compare densities and even compute simple Bayes factors. So a great place to start is with the scripts in the example folder, each of which has a complete worked example of a Bayesian model. And if you like the format, you can check out skeleton.m, which is a bare bones outline of a model fitting script that you can use to write your own. And if you try out matstanlib for yourself, I'd love to hear what you think. And if you want more context for any of the concepts I've talked about here, check out our Troubleshooting Bayesian Cognitive Modeling paper, which is in preprint, but we hope to have out by the end of this year. Great. Thanks for listening.